Hello. In this video, we are going to be learning about multiple representations of exponential functions. We're also going to talk about how to find and use multipliers based on percents. So like usual, our multiple representations are going to be a rule, table, graph, and situation. And for our situation here, we're going to say that I have 10 ants in my kitchen. This may or may not be true. And they are doubling every day. I really hope that doesn't happen. Okay, so that's our situation. Now we need to make a table, graph, and rule for that. So let's go ahead and start with kind of the general form of the rule. So exponential functions are always written in y equals a times b to the power of x. Sometimes we might do like a plus or minus something on the x, or we could do a plus or minus something on the end. That would shift it up or down or shift it side to side. I'm not worrying about that for this video. For this video, we are just focusing on a and b. All right, so for here, the a is always the starting value. And the b is the multiplier, or how fast it's growing. We're going to call it a multiplier so we remind ourselves that this is not slope that's being added on each time. It's a multiplier that something is multiplying by repeatedly. So a is starting value, b is multiplier. So here, my starting value is 10 because I have 10 ants in my kitchen. And they are doubling every day. So doubling is like times 2. So 10 times 2 to the power of x. It's that simple. Then we're going to make a table. And unlike sequences, we're going to start at 0. Because that's where things start, right? Sequences are special because they're like term numbers. We're not dealing with that right now. We're dealing with just a regular old function. We want the y-intercept to actually be the y-intercept, so we want it to be at 0. So I'm going to say that at day 0, at the start, I have 10 ants. And then after 1 day, I now have 20. After 2 days, I now have 40. After 3 days, I really hope I bought some ant traps because I will have 80 ants in my kitchen. Okay, then we are going to, and then let's label. So let's label what's going on here. This value right here, that is my starting value, which is otherwise known as A. Oops. That is the same A that is right over here, A. Then to see my B, that's what I'm multiplying by each time. Times 2, times 2. That's my B. We'll do A's in blue and B's in green. So that is my multiplier. And that's a times 2, not a 0.2. It's kind of not quite right. Okay, multiplier. So that's my B value. And I'll do that back in the original too. My 10 ants is my starting value. Doubling every day was my multiplier. Then we need a graph. I'm realizing now I should have used graph paper. You're using graph paper, so everything's good. So my x value is my days, because that's what was happening over here. My y value is the ants. And I've set up my scale. I haven't gone all the way to 80 because I didn't leave myself enough room for that. That's fine. We're just modeling in general what this looks like. So then I plot my points. Why did I not put 0 at 0? I'm going to fix that. That's better. 0 at 0. So 0 is 10, 1 is 20, 2 is 40, 3 is 80, which is off the graph, but I can see that it would be like, woo, way up here somewhere. So I can connect my points and show this going up. If I were to go backwards, right, there's no, yes, I'm probably not, I mean, in this context, actually, going backwards isn't that bad, right? That's like saying how many ants would there have been yesterday when I wasn't noticing them? And there were probably like 5, right? If it was doubling every day. So I could go back to a -1, and then that would be just halfway between. So I can show how this would be continuing down. I would never drop below 0 though, because that's not how exponential functions work. If I'm cutting things in half, I would end up with like fractional parts of ants, but I would still have those fractional parts. Of course, the model breaks down at that point. All right, so we've got our starting value. That is right here. That is our y-intercept. Y-intercept. So our y-intercept is when x is 0 and y is a. That is always going to be true. Then my multiplier. So I want that to be the slope, right? That like feels right to me for this to be the slope. But if you think about it, the slope changes every time. Right here, it's +5. Right here, it's +10. Here, it's +20. So adding on every time doesn't work. What it is doing is it's multiplying by 2 every time. So if I change that to show, it's not really, we don't normally write it like that, but we can think about that as being like a ×2. So I'm going to say the growth doubles each time because it's multiplying by 2 every time. So I'll just draw in my little, show that it's not the same every time. It is not a constant growth. It is increasing as it goes. And I'll go back over here and make sure we see that the rule here is 10 times 2 to the x. We often write it in parentheses because if you ever get negatives involved, it just is a lot nicer if you're using parentheses instead. So we'll write y equals 10 and then in parentheses 2 to the power of x. Both of those are accurate. All right, let's dig in a little bit more to multipliers because they're not usually something so convenient as just doubling. So let's say that I owe some money. I owe $100 to the utility company. I owe $100 my electrical bill, and I haven't been paying it on time. And so 10% interest is being added on to my bill every month until I pay it back. So we're gonna start out by making a table here. So pause, make a table for the first couple months of what this looks like for me. We're assuming I don't have any extra money being owed. It's just the interest that's being added on. So hopefully we are thinking that X is going to represent the months because the amount of money I owe is going to depend on how many months it's been, and that Y is representing the cost or the total bill. So 0 would be before any months have passed. It's just initially I owe $100. And then after 1 month, 10% interest has been added on. Well, 10% of 100, 10% of 100 equals $10, right? So that would be, now I owe 110. Okay, next month goes by, I still don't pay it off. So now I need to calculate 10% of 110. Well, 10%, that's like 0.1 or 0.1, right? Times 110 would give me 11. So now I need to add $11 on, 121 now. Another month goes by, I still don't pay it. 0.1 times 1.21, that's That's going to be 12.1. So that gives me $132.1 that I owe. This keeps happening, right? Now, my question is, this is an exponential relationship, because each time I'm growing by multiplying. But I'm also doing this adding thing that's making it so that I have to write my workout each time. And I think there's an easier way. So I want you to pause and I want you to try and figure out what's one number that I can multiply by each time that would give me the next answer. One number. Use a calculator. So did you decide to do the next number divided by the previous one? So if we do 110 divided by 100, that gives 1.1. If we do 121 divided by 110, that gives 1.1. So each time we're multiplying by 1.1. The other way to think about this is that each time I still owe the $100, but now I owe an extra 10%. So I owe 1 for the original, the whole of the original amount, plus 0.1 for the interest, which gives me 1.1 for what percent of what I previously owed do I still owe. Another way to think about that, 100% of the original plus the extra 10% interest is 110%, which is the same as multiplying by 1.1. So then I want to know, I'm really not on top of it. I don't pay it off for an entire year. After an entire year passes, how much is this going to be? Yes, you could extend the table all the way out, but I think we should write a rule. So let's use what we learned in the previous one to write a rule. So we know we're going to need a starting value and a multiplier. Our starting value is that initial amount that I owed. So y equals 100 times, and then this multiplier we came up with. Shall I color code this too? I love color coding. $100 is my initial value, and my multiplier is that 1.1 that we came up with. So 100 times 1.1 to the power of x. So then after 12 months, I can use my rule. I can say x equals 12, and I can plug in. Oops. So y equals 100 times 1.1 to the power of 12. And I don't expect you to do 1.1 to the power of 12 by yourself. You're going to use a calculator for that. So you're going to do 1.1 and then to the power of, so that happy little caret symbol, 12 gives me 3.138. I'm going to multiply that by 100, and I get $313.84. After 12 months, I would owe over $300. Don't let things collect interest, kids. Pay it off right away. All right, practice problem. All right, for your practice problem, you're going to write a rule for this table. Notice it starts at 0. This is not a sequence. You are going to write it in y equals a times b to the power of x form. Good luck.